This video is on section 1.1. It's about circles. It's going to go along with your homework number 16 in my math lab. There's a special form for a circle called center radius form, and this is what we're going to be wanting or trying to get in each of the problems. You know you have a circle if you have an x squared plus a y squared. An x squared plus a y squared. When we talk about circles, we mainly talk about the center of the circle and the radius of a circle. Now remember, the radius is from the distance from the center to the outside of the circle. I'm just going to start with the first problem, and you're going to see what we're talking about. Find the equation of the circle with a center at 3, -1 and a radius of 2. Now remember, I said to have a circle, I needed an x squared plus a y squared equals a radius squared. Now, just as we did in parabolas, I'm going to take this x, put it in this x parenthesis, but remember, when you go in or out of a parenthesis, the sign changes. So this goes in as a -3. When I am looking at the y, which is -1, it's going to go into this parentheses as a +1. Now remember, here I want radius squared, so if r is equal to 2, r squared is going to equal 4, and that would be the right side of my equation. Now, to graph this, and this is going to be kind of hard for you to see because my graph is so tiny, I'm going to go to the center point, which is +3, -1. Now the radius is the distance from that point to all points on the circle, so I'll go up 2 units, right 2 units, down 2 units, left 2 units, and I'm going to try to draw something that looks like a circle. Not very good. Alright, number 2, we're going to just go in reverse. This time they've given us the equation, and we want to find the center and the radius. Now remember, center is a point, an ordered pair, radius is a number. For an ordered pair, I need an x. I'll take this x, change the sign. I need a y. I'll take this y number, change the sign. This 9 is radius squared, so I'm going to take the square root of it, so my r is 3. Again, find the center and the radius. Center is an ordered pair. Radius is a number. Now, there's no no number that's been added to this x, so my x is 0. There's a -1 with y, it comes out as +1. This 16, remember, is r squared, and if you take the square root of 16, that's going to be 4. Remember, if you come out of an equation, you take the square root of the r. If you go into the equation, you square. Alright, one more on this page. Write the equation of the circle. Now remember, I need an x squared plus a y squared equals a radius squared. I'll take the x, change its sign. I have a 0, I'll just write it in. This square root of 5 is my radius, and I want radius squared. So let's clean this up. This will be x plus 3 squared plus simply y squared. Now, if you square that square root, you undo, and all you have there is equal 5. Okay. The back of your work for this, on this worksheet, we have a situation here where the problem is not in center radius form. You see that we do not have parentheses. Everything's been multiplied out. We have to get this to center radius form, and now we're going to go back and be forced to use complete the square. This was a method in 2.3 part 2 that I gave you an exact set of notes of how to, rules, but we haven't used it much. Now, to do this, we're going to separate our x's, separate our y's, and we're going to move the constant to the other side. Now you're only going to do this if you see the squared term and an x, and here the squared term and a y. Now here's what we are going to do. We're going to look at the coefficient of the x term, which is 6. You're going to half that, you get a 3, then you're going to square that and get a 9, and we're going to add that 9 to both sides. And we're going to do the same thing with the coefficient of y, which is 4. We're going to half the 4, and get a 2. Then we're going to square that 2 and get a 4. We're going to add that to both sides. Now, this is a perfect trinomial square, and this is a perfect trinomial square. And I promise that this is going to become a binomial square. Now, the simplest way to reduce this is to take the square root of the first term, which would be x, take your middle sign, square root of the last term. Now, put your plus in for the circle. Now, we're going to do the same thing here with this trinomial. Take the square root of the first, use your middle sign, take the square root of the second, equals 9 plus 3 plus 4 is going to be 16. Now here's my equation in perfect square center radius form. Now I know that the center is going to be 3, negative 2. I changed those signs. This is radius squared, so my radius itself is going to be 4. Alright, problem number 6. We have the same thing. I see an x squared and an x, so I'm going to separate my x terms. I'm going to separate my y terms. Notice we only have one. I'm going to move the constant to the right side. Now, I'm going to work with the 4. I'm going to half that 4, get a 2, and square that 2, and get a 4, and I'll add that to both sides. There is no y with the y squared terms, so I'm complete there. This is my perfect trinomial square. Now remember, square root of the first term, use your middle sign, square root of the third term, bring down the y term, and add. Now, my center is 2 for x, nothing, 0 for y. R squared is 12. Now, if I take the square root of both sides, I need to look and see if I can simplify this using perfect squares. That would be 4 times 3. The square root of 4 would be 2 onto the square root of 3. So my radius is 2 times the square root of 3. I think I'll save the next 2 problems and do those on a separate, really short video.